Hello everyone, this is educational material prepared on engine fundamental, and this material is the 11 part, and it is on the engine operating systems. The learning objective. After the presentation, the student shall be able to explain the ignition system purpose, construction, and operation. Carry out minor ignition system service. This picture shows the ignition system of conventional vehicle. So the ignition system starts from the battery and the ignition coil, distributor, and the spark plug. The ignition system. The gasoline engine uses a spark to ignite the combustible substance in the combustion chamber. The spark is produced when the high voltage cell jumps electrons from the center electrode to the side electrode. The gap between the electrode has high resistance, and to overcome the high resistance, the ignition system must be capable of producing as many as 30,000 volts. This amount may vary from vehicle to vehicle. The higher secondary voltage forces electrical current or electrons across the spark plug gap. The intense heat created by the electrons jumping the gap ignites the air-fuel mixture surrounding the electrode. Type of ignition system. The ignition system can be classified as magneto-ignition system, battery ignition system, electronic ignition system. The conventional ignition system include the magneto-ignition system and the battery ignition system. They both don't have computer. Most small gasoline engines use magneto system to supply ignition spark. Magneto system produce electrical current for ignition without any outside primary source of electricity. Magneto ignition system is an ignition system in which magnets are used to produce high voltage for the generation of electricity. They serve as simple and reliable ignition system. The basic part of a magneto system include transformer core, contact breaker, cam, capacitor, ignition switch, distributor, spark plug. The picture illustrates the major part of a small engine magneto system. The magneto ignition systems are commonly used in small engines such as lawn mowers, chainsaws, and generators due to their reliability and independence from external power sources. Working principle of magneto ignition system. In the magneto ignition system, magnets are used. When the engine of the system starts, it helps the magnet to rotate and produce energy in the form of high voltage. One end of the magnet is grounded through a contact breaker, and the ignition capacitor is connected to its parallel. The contact breaker is regulated by the cam. When the breaker is open, current flows through the capacitor and charges it. Now the capacitor is acting as a charger. The primary current flow is reduced, thus reducing the overall magnetic field generated in the system. This increases the voltage in the capacitor. This increased high voltage in the capacitor will act as electromotive force. This produces the spark at the right spark plug through the distributor. Magneto ignition system application. The magneto ignition system is widely used for the following application. This system is used for the generation of electricity In the case of battery system, their battery is used and to run the vehicle. It is used in two-wheeler vehicle as an engine. Also used in various places like tractors, outboard motors, washing machine, bus, power unit, marine engine, and natural gas engine. Battery ignition system. A battery ignition system is used in the SI engine for supplying the power to the spark plug for the generation of a spark to burn the air-fuel mixture in the SI engine system. In the battery ignition system, the spark is produced by the secondary coil induced electromotive force. Battery ignition system construction. The battery ignition system has the following components to work properly: battery, ignition switch, resistor, ignition coil, and the distributor. And in the distributor, there are different components: the contact point, the rotor, and the cap, the distributor cap. And the high tension cable, spark plug, and the green line, the green color indicates the primary circuit line, and the blue is the secondary circuit system. Ignition switch. The ignition switch is the electrical part of the ignition system which control the electrical circuit to allow and disallow the electrical power distribution of the battery to the electrical system. The ignition switch has four functions. The ignition switch of the gasoline engine has lock, accessory, on, start positions. And nowadays, the modern vehicle use start-stop type of button. Battery. The battery is the storehouse of the electrical energy of the vehicle. Its main function is supplying electrical energy to the load while the engine is off. The battery supplies electrical power to the ignition system, starting system, charging system, lighting system, etc. This is the 12-volt battery, and this is the handle and two pulses, the plus and the minus, the positive and the negative terminals of the battery. This is the internal construction of the battery. So the cutaway of the battery shows the internal part of the battery: negative terminal, positive terminal, the cell divider, the positive electrode, lead oxide, and the negative electrode are the lead, and the dilute tungsten, which is sulfuric acid. The ballast resistor. The ballast resistor is connected in series to the primary coil of the ignition system. It controls the amount of current passing through the primary coil. It is made up of iron, and iron has property to increase electrical resistance rapidly by an increase in temperature at certain limit. Ammeter. It is an electrical measuring instrument used for measuring the current supplied by the battery. It is located on the dashboard. Ignition coil. The ignition coil is accountable for producing high voltage surge to ignite air-fuel mixture. It has two coils, primary and secondary. The primary coil is shown here and the secondary coil is shown here. So they are kept in a single housing, and we call this ignition coil. Primary winding. The primary winding has 200 up to 300 turns. This is the primary winding. So the number of winding between 200 and 300. The current which is flowing through the primary winding creates a magnetic field. Secondary winding. The secondary winding has 21,000 turn of 40 gauge wire which is insulated to withstand high voltage. So the voltage supply to the spark plug is the secondary voltage. Contact breaker. The name itself indicates contact breaker. It means adding and breaking the primary circuit to the ignition coil. The function of the contact breaker is current flow in an ignition coil when it is closed and flow stop when it is open. In the above diagram, you can see its operation. Capacitor. It is similar to an electric capacitor. Generally, it stores electrical energy in electric field. In capacitor, two metal plates are separated from each other through the air, which is an insulating material. Distributor. Distributor is the unit of the ignition system. Its purpose is to distribute the spark for the cylinder according to the firing order of the engine using the high tension cable and a spark plug. The distributor has so many parts: distributor cap, rotor, contact breaker, condenser. There are two different types of distributor: brush type and gap type. High tension cable. The high tension cable is made up of conductor, internal and insulator, external material. It carries high voltage of the secondary coil between distributor and the spark plug. Spark plug. The spark plug is where the electrons jump to produce a spark in the combustion chamber. It has two electrodes, center electrode and side electrode. The center electrode is the one located here, and the side electrode is the one which is located here and connected with the body or the ground. So there are different type of spark plug according to the material and also the length. Battery ignition system application. The following application of battery ignition system. Firstly, battery system is used in SI engine for producing the spark to the spark plug. It is also used in light commercial and modern vehicles which are having SI engine. Electronic ignition system. Electronic ignition system is now fitted to almost all spark ignition vehicles. This is because the conventional mechanical system has some major disadvantage. Why electronic ignition? Mechanical problems with the contact breakers, not the least of which is the limited lifetime. Current flow in the primary circuit is limited to about 4 ampere, or damage will occur to the contact, or at least the lifetime will be seriously reduced. Legislation requires stringent emission limit, which means the ignition timing must stay in tune for a long period of time. Weaker mixture require more energy from the spark to ensure successful ignition even at a very high engine speed. These are some of the points why manufacturers transform into electronic ignition system. The picture illustrates the two different types of electronic ignition system. This is the distributor type of electronic ignition system, and this one is the distributor-less type of ignition system. So the distributor and the ignition coil, and here we have electronic control module, and this control module controls the ignition system. And here magnetic pickup, armature or reluctor is located inside, and there is also a vacuum advance mechanism. The latest version of the electronic ignition system is the distributorless ignition system. So in the case of the distributorless ignition system, the cylinders have their own igniters. Advantage of electronic ignition system. Following are the advantage of electronic ignition system. Moving parts are absent, so no maintenance. Contact breaker points are absent, so no arcing. Spark plug life increased by 50%, and they can be used for about 60,000 kilometers without any problem. Better combustion in combustion chamber. About 90 to 95% of air fuel mixture is burned, compared with 70 to 75% with the conventional ignition system. More power output and more fuel efficiency. Type of ignition system. Ignition system type can be differentiated by the method used to distribute current to the spark plug, either the conventional type in which a distributor is used, or DLI or distributorless ignition, and DIS or direct ignition system in which no distributor is used. Conventional ignition circuitry. The microprocessor in the ECU determines the ignition timing based on the G1 and G2 and NE signal, as well as on signal from each sensor. After determining the ignition timing, the ECU sends the IGT signal to the igniter. When the IGT signal goes off, transistor TR2 and the igniter goes off. As a result, the primary current to the ignition coil is interrupted, causing a high voltage of approximately 20 to 35 kV to be generated by the secondary coil in the ignition coil. This in turn causes spark to be generated by the spark plug. The igniter incorporates the following circuitry in order to deliver a stable secondary voltage and assure system reliability. Dual angle control circuit, IGF signal generation circuit, lockup prevention circuit, overvoltage prevention circuit. This is the circuitry for the electronic ignition system. So the ignition battery, ignition switch, ignition coil, and the igniter, and the engine ECU, and the sensor information, and the crankshaft position, and the camshaft position center. Distributorless ignition system. It is an electronic spark ignition system which distributes high voltage directly from the ignition coil to the spark plug without the need of a conventional distributor. ECU, igniter, ignition coil, spark plug. DLI systems overview and the conventional ignition circuitry, ECU, igniter, ignition coil, distributor, spark plug. DIS, direct ignition system. Similar to DLI, DIS is a system to distribute the high voltage directly to the spark plug from ignition coil without using a distributor. There are various types of current DIS systems, including those in which an ignition coil is provided for each cylinder and those in which an ignition coil is provided for every two cylinders. Control by the engine ECU is basically the same as that of an ordinary ISA. The difference is that the engine ECU has the same number of IGT signals as the number of ignition coils. IGT signals are then sent to the igniter according to the ignition sequence. Electronic Spark Advance System. The ESC or Electronic Spark Advance System is a system in which an ECU, rather than a mechanical advancer, controls the ignition of the ignition system. Thank you for watching this video. If you are interested, please share with your colleague.